Welcome, and thank you for joining us for Data Mark session, GIS, for the public safety professional, the legacy to NG9-1 transition. I am Sandy Dyer from the Data Mark team, and I'll be the moderator and co-presenter for today's session. Also with me is Stephanie McCowitz, who is going to help support us with the Q&A portion and any chats that may come through as far as questions. And also co-presenting with me is Annie Cahill. I'd like to let everyone know that we are recording this session. All attendees have been muted for quality assurance purposes, but we do encourage the questions through the Q&A section of the platform or the chat, as I mentioned. I believe it's just a Q&A that's available here, but nope, there's a chat as well. Fantastic. Hi, Miss Amy. I'd like to introduce my co-presenter, Annie Cahill. Annie, can you share a little bit about yourself, please?
Hey, everybody. My name is Annie Cahill. I'm a GIS technical manager with DataMark, and I provide technical oversight to all of our projects nationwide. I also lead our strategic planning efforts and our boundary facilitation workshops. I've spent 15 years in local government GIS before coming to DataMark in Virginia. I live in Virginia. I'm on the board of directors for GIDA, which is the Geospatial Information Technology Association, and also on the board for the GIS Certification Institute. I'm really excited to be here talking with you guys again to continue our discussion about GIS and how we use it to support public safety. Thank you.
Thank you, Ms. Annie. And for those that don't know me, my name is Sandy Dyer. I am a public safety expert with DataMark. I have traditionally a public safety background. I started in public safety in 1990 as a public safety dispatcher and have had both the blessing and the heartache of growing up with 911, the good, the bad, and the ugly, every aspect of it. I've performed multiple roles in my career, from public safety dispatcher, 911 operator. I was a master street address guide coordinator and MSAG coordinator. We'll talk about our MSAG a little bit today. I was also a county coordinator where I was responsible for the network, equipment, and budget for 9 911 centers under my 911 system. And then prior to joining DataMark, I was a project manager with the State of Arizona 911 Program Office, where I supported everything from PSAP operations, wireless deployments, GIS, and then also participated in our early adoption of next generation 911 geospatial routing. And I'm hoping to share a little bit of those experiences today, but I won't bore you too much with the details. So today's agenda is short, but we have a lot of content to cover. And anyone who's participated in a webinar with Annie and I knows that we really enjoy questions. We like it to be a little bit more informal because we feel that that's the best learning environment. So please, if you have questions, drop it into the Q&A or the chat. We'd really love the opportunity to address those for you. We are going to talk about today's legacy 911 system because I think the best way to understand what we're moving towards is to understand how business is done today. And I know in my experience that when I was a public safety dispatcher, I just knew that they showed up and it was magic how they showed up. And I didn't really understand how they showed up. And I find it fascinating about how calls actually get to me. So we're going to talk about how it's done today, but then also what we can expect from next generation 911, how that legacy call routing today changes in the next generation 911 system. And then we're going to have a very important conversation about NG9-1 readiness path. And while this is going to be more focused on the GIS and the data, for our public safety folks that are attending, please hang on for this part of this discussion because so much of this is driven by you, your programmatic planning, your knowledge, and actually being the user in the next generation 911 system, and your participation is necessary, okay? Now, for those that joined us the first time for GIS Basics for the Public Safety Professional, you'll remember that when we got together, we actually discussed the basics of GIS and how GIS supports the PSAP, the Public Safety Answering Point, which is just a fancy term for a 911 center. When we talked about GIS and the PSAP, we talked about the 911 mapping, we talked about CAD, we talked about automatic vehicle location, closest unit routing, search areas, and how GIS supports all of this. In today's session, we're actually going to focus on the other side of the golden line, and that golden line being the 911 golden line. And we're going to talk about the GIS that actually is needed to support a 911 call, how that 911 call will get to you in the next generation 911 environment, so that you're able then to use GIS again in order to send your emergency responders. And ideally, this should be the same GIS on each side of the 911 golden line. The GIS supporting the 911 call should be the same GIS that you're using in the 911 center to send your emergency responders, as much as those two different business needs can be supported by the same data set. I do really want to reinforce the fact that this is a high-level discussion. Even the graphics or the call flow representations are not going to have every component of a call flow that's in there, because we're really just going to focus on those two topics today. How do I validate? How does a call get validated? How does it get in the 911 system, the location itself, and how does it route to you, both from a legacy and an NG9-1 perspective. And the reality is 911 is very local. It's a very local concept. And so while we're going to talk about some generalized concepts of legacy and next generation 911, these concepts may be similar to how you do business today, but they may also be different, just because, 911 is local, right? Okay, so let's start with our discussion on the legacy 911 system. And like I said, I feel it's important that we share both descriptions of legacy and next generation 911, just to enhance our understanding of why things are going to be different. But again, just want to stress, this may be how you do business today, and it may not. So let's start by going over a description of a legacy 911 call flow and the associated location data. Okay, so we're going to focus on the landline 911 call with the understanding that the same process today is used to support our wireless calls as well. So for example, the physical address of a home or a residence is used for a landline call, while in wireless and the legacy system, the location of the cell tower is supported, since today's network isn't capable of supporting a caller's location by latitude and longitude for call routing. Now, today's 911 network is a voice-only analog network. So as part of a 911 call, when someone dials 911, what's captured as part of that 911 call is the voice and the telephone number. Much like your caller ID at home, like a home phone call, the voice and the telephone number are captured. That voice and telephone number are sent to your telephone company's central office, and the central office says, oh my gosh, that's a 911 call. I have to do something special with that. I'm going to send it to the 911 selective router. The voice and the telephone number are sent to the 911 selective router. And in the selective router, you have what's called a selective router database. And that telephone number is sitting in that selective router database. And it's looked up, and it's looking for what's called an emergency service number, an ESN. The ESN tells the 911 system what 911 center I'm supposed to route this call to. The voice and the telephone number are sent to the PSAP assigned to the ESN. We'll call it PSAP A. So PSAP A receives the 911 call. It's the telephone number and the voice are delivered. The telephone number is then sent out over special circuits. These are special data circuits called ALI circuits. And it's going out to your 911 database, which includes your MSAG and your ALI, and we'll talk about that in a moment. Now, that could be a local ALI bid, or that could be provided by an ALI database provider. So for in our example, where I grew up, that was sitting in another state. That location information is grabbed based on the telephone number, and it's pulled back into the 911 center, and it happens so fast, the dispatcher doesn't even notice a disconnect. They don't notice that the voice and the telephone number came one way, that information was sent back out from their PSAP and pulled back in to bring location information in. So what are those 911 databases? What are the 911 databases? That didn't even sound right. What are the databases out there that support legacy 911? So again, from an extremely high level overview, let's talk about them. You have one, the automatic location information database. This is your ALI database. For most dispatchers, This is, you know how you have your ALI 911 screen? It's that tiny little 512 character screen that shows up, and the physical location of the caller is on it. That comes from the ALI database. The ALI database is all the customer records out there. So when I get a new home phone, that telephone number, I provide an address to my telephone company. That address becomes a part of the ALI database. Now, so it's my house number, it's my street name, it's my community name, and it's the state that I'm in. Your telephone company then will bounce it up against what's called the Master Street Address Guide, the MSAG. Now, the MSAG is generally managed by someone locally in your community. If you don't know who your MSAG coordinator is, find out, because you want to hug this person because they support everything you do every day from a 911 perspective, right? They're the ones who make sure that your 911 network is working well. But the MSAG is a series of address ranges with a community name and a state associated. And all of these address ranges, being low, high, your street name, the pre-directional, all those things, is a geographic representation of your community. And for every single address range, an emergency service number is applied. Now, this ESN is going to do two things for you. It's going to, one, tell the 911 system, hey, route the call this way. And then the second thing it does is when you receive that 911 call for our public safety dispatchers, it tells you the PSAP, law, fire, and EMS that are associated with that landline call. Now, in order for the selective router database to know where to route that 911 call, where do I send that telephone number to that PSAP, it has to be bounced up against the MSAG, and the MSAG says, give it this ESN. This is where it's got to go. Now, the same thing is true from a wireless perspective, except it's really about the wireless location. The cell tower itself has nothing to do with the wireless phase 2 coordinates, the approximate location of our caller by latitude and longitude, because today's legacy network doesn't really have the ability to capture the caller's location as part of the 911 call and route based on the caller's location. That's why we're wanting next generation 911. Oops, sorry, I had some animations here that didn't get through. So then what's the result? So the result is our 911 screen. This is our 911 ALI screen, or at least a representation of it. And again, just like how 911 works today, every one of our 911 screens in every 911 center may look a little bit differently. But when we receive that physical location, our 911 map is going to map that for us. Or when we receive the approximate location of our caller by wireless phase 2, latitude and longitude, it will map that for us as well. So these are just a couple of descriptions of the end product of the legacy 911 system. And I don't think we have any questions so far. Okay, just wanted to stop and make sure. I think I didn't pull up the Q&A.
Actually, Sandy, we do. I just saw. Okay. Bill asked, are accented characters supported, and how does Endor 911 with Ray-Bomb Act? I'm assuming he's asking about what are the implications of the Ray-Bomb Act for 911.
So special characters are not supported in a legacy environment. Special characters can be supported in a next generation 911 environment, but that's not really the depth of discussion we're going to go into today. So an example of special characters, say with a real-time text call, in a full real-time text to real-time text deployment within a next generation 911 network, can support special characters. And anyone who knows me knows I'm passionate about real-time text. I co-chair the NENA Real-Time Text Working Group, and the real-time text document has been finalized and is publicly available. And it describes how real-time text functions in today's legacy network, as well as what's needed in the next generation 911 network for that to be supported. Special characters can be supported in the next generation 911 network associated to real-time text calls. Some special characters, well, let me qualify by saying some special characters are supported in the legacy network today, but it's strictly through TTY, which you know is more like a dial-up modem type of communication with the 911 center. And so it's not special characters as you would normally as you would normally describe a special character, the way we're used to saying it in today's communication environment. 3D elevation, the plus or minus 3 meters, your question on that, Bill, that is actually part of the FCC requirements. Of course, there are still efforts in place on how to support that, both from the wireless carrier side and the 911 network side. And if you're interested in that topic, and if you're not already participating, the National Emergency Number Association, NENA, does have a 3D work group that's currently tackling those questions now. And what we can do is share out NENA's website and how to join that work group if you're interested in finding more information on that. But the 3D elevation, the plus or minus 3 meters, is actually an FCC regulation on the wireless carrier side. And then from a 911 perspective, we have to figure out how we're going to support that in our network. I hope those answered your questions. Okay. So let's talk about next generation 911. Again, really want to reinforce, folks, this is going to be a high level discussion. Not every component of NG9-1 is going to be discussed here, or is it going to be represented, because we really want to keep our conversation narrowed to call processing and call validation and routing. Okay, so before we talk about what the NG9-1 network looks like, let's discuss what next generation 911 is. Next generation 911 is a complete replacement of how we do 911. Folks, the first 911 call was placed in 1968. And basically, we've seen improvements in the network since 1968, and we've improved how we've done business. But it's basically been the same network since 1968. So in order for us to move away from this voice-only analog network into how we communicate today, which is mostly data, we have to improve how we do 911. And that means we have to completely replace how we've done business. So what does that mean? We're going to replace our voice analog network with an IP network. It's called an ESINet, an emergency services IP network. It's an internet, but this is a specialized internet with special protocols, and it's secure. So it's not like you're going to do your Amazon shopping on this IP network, but it's a specialized emergency services network that will support both voice and data, and that's very important. The other thing we have to replace is our 911 call handling equipment. And we have to replace our 911 call handling equipment because we need equipment that can not only communicate with this new IP network, but it has to be capable of now processing all those new types of 911 calls that we plan to see, whether it's picture, video, real-time text, alarms, automatic crash notification information. There's all this new way of communicating that's going to be able to be supported. And we need equipment that's capable of doing that. And then the other component of it is replacing that MSAG and ALI and that tabular system that we've been using today to support 911 with what's called a next generation core services network. And this next generation core services is actually going to be your new selective router, your emergency services routing proxy. It's going to be your policy routing rules. It's going to be the GIS that's going to support location validation and call routing based on the caller's location. Now, in the new network itself, for that location validation and call routing, you're going to see new GIS data layers. Now, some of these data layers are going to look very familiar to you because they're data layers that you use in your 911 center today in order to send emergency responders. They're going to look similar, but what we'll need that GIS to do is slightly different in the 911 network, because what we need the GIS now to do is actually route the 911 call, not route the emergency responder. So two different business names, needs, same GIS data set. So an address point layer, you're going to want an address point layer in your next generation 911 system to help validate those physical locations. So those ALI records that we talked about, your home address, we want to know that there's an address point out there that's going to validate that as being, yes, this is a good location, and this location is supported by my 911 system. But if an address point isn't available or can't be located, then we have road center lines. And the road center lines then say, if my 911 call comes in with a physical location, it says, well, there's no address point to support it. So is there at least a road center line to support it? And your road center line is similar to your MSAG entries. And then for call routing, instead of having an emergency service number, you're going to have what's called a PSAP boundary, a public safety answering point boundary. And this boundary is going to say, based on this address point or this location on the road center line, this is the 911 center that's going to support my 911 call, and this is where you route it. Your other service boundaries like law, fire, and EMS are also represented in the GIS system and will support your call routing. And then we have what's called a provisioning boundary. We're not really going to go into the provisioning boundary, but basically for the GIS folks and the public safety folks out there, your provisioning boundary is telling your 911 system, hey, if there's a problem in the system, this is where you need to send it to get fixed. For some reason, my scroll doesn't want to work. Excuse me. So let's talk about the NG9-1 call flow and location data. So remember, in the legacy environment, we receive the call, it's a voice and it's a telephone number, and it's sent to the 911 center. And then once it's received at the 911 center, it goes out and pulls our location information in. One of the first things that's so fantastic about next generation 911 is that location information is captured at the time of the 911 call. And it's captured through this really awesome protocol called Pitfall, Presence Information Data Flow Location Object. We're not going to go into a heavy deep dive on that. We'll talk about it a little bit, but that's the element that says now we can capture location at the time of the 911 call. Why is this important to us? Well, we're not able to route wireless calls today, the latitude and longitude associated with our wireless phase 2 coordinates, wireless phase 2 meaning the approximate location of our caller, because that information comes after we deliver the call to the 911 center. But Pitfall and the fact that location is able to be captured at the time of the 911 call allows us to have a network that can do so much more than what we are able to do today. Now, there's a lot of contingencies on that. It's contingent on whether or not the wireless carrier can derive the caller's location in enough time that it's delivered. But it puts us into a network that has more possibilities beyond what we have today. So when the call is received by the 911 network, it actually hits the emergency service routing proxy, which is our new selective router of today. The emergency service routing proxy is going to send the location of the caller, whether it's a physical address like 123 North Main Street or a geodetic location like latitude and longitude, and it's going to send it to the emergency call routing function. The emergency call routing function is where it's going to say, yep, I found an address point. Yep, I found a road center line. And you know what? There's a PSAP boundary here, and I want you to route this call based on this point and polygon. It's called a spatial query point and polygon routing. And that's going to be true whether or not it finds an address point or the road center line to support our civic locations, or if it's a latitude and longitude, it doesn't need those. It just needs to find a PSAP polygon and route our call. So the emergency call routing function says, yep, this is where I think you need to send the call. Sends that information back to our emergency services routing proxy right here. And in the ESRP, we have what's called a policy routing function. And in there is policy routing rules. And you can build these very intelligent rules on what to do with 911 calls. Again, another functionality we really don't have today. Some of these rules are going to be basic functionality that we do have today, like default routing and that type of thing, but also have time of day routing. If a PSAP is unavailable, it has its intelligent way of rerouting those calls. It has a whole bunch of rules that are in it. We're not going to go into a rule discussion today, but I want you to know it's way more intelligent than how we do business today. So if the emergency service routing proxy agrees with the emergency call routing function, there's no rule to change its mind, say it's not a time of day routing affecting it, so we can send it to PSAP A, then we'll go ahead and route the call to include the location to the PSAP. That was a convoluted kind of description of how it works today, and I apologize. But I hope what you're really kind of getting out of this discussion is how much better we're going to be able to function from a next generation 911 environment.
Hey, Sandy, we did have another question come through.
Yes,
does NG9-1 require specific address assignments for each 5G/small cell deployment?
That is a great question. No one's asked me that before. So within the next generation 9-1 data schemas, there is a cell sector data schema layer. There is a cell sector layer. I don't remember all of the attribution that goes with that. But if we can capture that, if you're not familiar with the data model, let me send that to you and the specific schema, and we can continue that conversation offline. I do apologize that I don't have that. So the cell sector layer isn't one that, it's not one of the required layers for next generation 9-1 to work, because really what we need is a location and a PSAP polygon to be able to make it work. So I have to admit, I haven't necessarily paid as close attention to the cell sector data layer, but would love to be able to have that conversation with you if that's okay. So let's continue. So the location validation function. So I'm going to talk about two components that support GIS for those GIS professionals that are with us today. One is the location validation function, and then the other is the emergency call routing function, as I mentioned, as part of the call flow. The location validation function is our new MSAG. It is going to hold all the GIS data sets that we have, and all of the originating service providers, even you as a local data authority, are going to be able to validate your information within the location validation function. This is going to be all pre-call validations. We want to make sure prior to a 9-1 call being placed that the 911 system can actually support that 9-1 call. And that's what the location validation function does. The other component that's going to hold our GIS is the emergency call routing function. It's going to hold an exact replication of the data that's sitting in the LVF. Why? Because we don't want to route emergency calls on GIS data that we didn't use to validate the call before it even got there. So the LVF and the ECF are going to use two exact same data sets of GIS, except the emergency call routing function is actually going to perform the actual emergency call functions. LVF is pre-call, ECRF is active call. It's actually going to use the spatial point and polygon query to support the geospatial call routing. Now, just a little bit of explanation on Pitfall, and this is more for our GIS folks, so you can understand why your GIS data is so valuable. So Pitfall is actually a series of location elements associated to XML tags. And this is an IETF standard. This is not a NINA-specific standard. This is a standard that has existed for quite some time in multiple business industries. This is our adoption of this same type of standard within 911 to support location. Now, what happens within a Pitfall environment is it's actually looking for the highest common denominator to the lowest common denominator in corresponding data elements. Meaning it's going to take a look at every data element that's coming a part of the 911 call. So here on the right side, this is an example from our standards of Pitfall. And it has our country is US, the state is Ohio, the city is Columbus, the road name is airport, the street type is drive, the house number is 2901, and so forth. When that Pitfall element captures that location information in these XML tags, it's going to be looking in the ECRF at your GIS data for where there's corresponding data elements to support it. At the point that it finds corresponding elements, but then doesn't find it, that's the lowest common denominator that is going to support the call routing. So if the Pitfall elements have sub-addressing, but your GIS data doesn't have sub-addressing, it's going to stop at the house number. If that makes sense. Now, once this correspondence has happened, it's then going to bounce that location against whether that's an address point, a road center line, or a latitude and longitude. It's going to bounce it up against the PSAP boundary to say, where do I send this 911 call? It's that point and polygon query that's going to happen. And then that information is sent back to the ECRF or to the ESRP for routing. Now, just a couple more things I want to jump into before I turn it over to Annie to talk about data readiness. Legacy and NG9-1 transitions. So this is going to look differently for everybody. There are going to be some areas you're going to go from a completely legacy environment into a full-blown end-to-end NG9-1 environment. Those can happen. But for most of us, we're going to be kind of in a transitional state. We're going to be kind of half in legacy, half in NG9-1 as we get this figured out. And why is that? A lot of it is next generation 9-1 planning. There are governance concerns, there are funding concerns, there is some basic needs that may have to be addressed first before we get into other needs. And part of that planning is taking a look at what we look like today, what is our governance, what is our funding, what is our ability to move forward? Do I want to deploy just as my local PSAP? Do I want to be deploy as part of a regional solution? Do I want to deploy as a statewide solution? And then what are the local needs that I'm needing to support while I go through this transition? So for like our experience with early adoption, we were not a full end-to-end I3 solution. We were a transitional state to some extent, although we were able to deploy geospatial routing. And part of those decisions kind of came down to CAD. I mean, our PSAP said, we'd love to do this, but our CAD can't support everything that next generation 9-1 wants us to support. And so we said, that's okay, because I know your GIS professional made sure that both a next generation 9-1 environment and a legacy environment can be supported from a GIS perspective. So we're good. We're good. We'll deploy it as far as we can with you. We'll leave the legacy components in there that we have to. And then, of course, part of it, it goes back to what I had mentioned earlier about the capabilities of your originating service providers, their ability, what their abilities are, their ability to connect to your next generation 9-1 network. And then frankly, folks, it's going to come down to whether or not you have the GIS data available for geospatial routing. Now, I can deploy, so a lot of communities are deploying their EZNet first because they're wanting to move away from their legacy network, that legacy voice analog network, to your EZNet. So a lot of them are deploying the EZNet first. A lot of us need new 911 call handling equipment. It's just outdated, it needs to be refreshed, so that's moved high up on the list. And the geospatial routing components, the GIS data is left for last. And that's understandable because, again, that's 911 planning from a needs-based perspective. What I'd like to encourage, though, is because the GIS data for geospatial routing takes a very long time, takes a lot of planning and a lot of resources and a lot of new stakeholders, that you actually try to do your GIS data readiness in tandem with your other aspects of your transitional deployment. And Annie's going to talk about what are some of those things that we need to consider as part of our readiness plan. Annie?
Yeah, thank you, Sandy. Good explanation of everything. I hope I can be as exciting as Sandy. So when we start talking about NG9-1 and Cad validations, they're really two different things, okay? But validations in general ensure data integrity. That's the purpose. Whether it's tabular or spatial data or both, validations ensure the integrity of the data. All right, so Cad validations are usually for 911 needs, generally not spatial, so they're not really meeting GIS needs always. Usually GIS is used within Cad mapping solutions for closest unit routing or resource routing to the 911 caller. Because the function of GIS and NG9-1 is to get the 911 call to the correct PSAP, it does require different validations. So the GIS data that we're using today was really built to support different business needs, and it requires that we look at the data differently for the business needs of NG9-1-1. So it's not that the data is wrong, it was just built for different business needs. Okay. So the path to NG9-1 readiness really involves a look at the legacy data currently being used to route calls and ensure that it matches the GIS data. It's really a look at all of these different things. It also means that our workflows for creating and maintaining the GIS data support the NG9-1 requirements for accuracy, completeness, and quality. Because like we mentioned, for NG9-1, our GIS data has to have a different role, right? But we also still need to make sure that our legacy data is working. The path to NG9-1 readiness can be challenging, but with thoughtful planning, you can make the process easier. Many of us are inclined to jump directly to the GIS data and look at NG9-1 as solely a GIS data issue. And while that's ultimately true at the end of the day, when everything is said and done, the GIS data needs to support NG9-1, other factors contribute to the data quality. And we're going to discuss those in the upcoming slides.
Now, I do want to mention, so we have identified a purposeful order here being from MSAG, Centerline Comparison to data maintenance. And while we're going to describe this purposeful order today in a linear fashion, realize that your purposeful order may be different for you depending on where you're at in your deployment and where you're at in your GIS. So don't get hung up on the linear fashion of this. Just realize that what we're trying to stress here is that a purposeful order is necessary and it should be a thoughtful process. There you go,
Thanks,
Annie.
Sandy. So really the first step for NG9-1 readiness, and when we talk about planning, we really need to take a look at the stakeholders. So traditionally, when we think about 911 or public safety, we often limit ourselves to those stakeholders, right? So fire, police, EMS, and 911. However, NG9-1 really adds to the list of our public safety stakeholders just because of the role in the way that data is maintained or the way that it moves through your locality. So for example, planning and zoning might be the addressing authority for your county or your locality, while public works might be responsible for managing and maintaining the road center lines. We actually work with a client who when their addresses are assigned for their county, this is a really big county, the addresses come from one department, just the address number, the house number, and the street name comes from another department. So there's multiple departments involved in their addressing workflow. GIS is obvious because we do know that GIS is becoming kind of the heart and soul of Next Gen 911. And I think that a lot of GIS professionals don't understand the impact that NG9-1 will have on their roles because really we as GIS people are now geospatial first responders. That's basically what's happening with NG9-1. So it does expand our list of stakeholders, and it can even go outside of this, right? Like you could also include the assessor's office, depending on who's involved in these different workflows. So it's just very important to identify these stakeholders because these are going to be the key players as you're planning out what you need to do to get ready for Next Gen. So after we've identified our stakeholders, we need to look at our next steps. And the next steps are really meeting with each individual stakeholder to gather information about anything and everything that's related to managing and maintaining our data and workflows pertaining to NG9-1. So we can really break this down into two different sections. So really it's the workflows and business processes, and then also the GIS quality, okay? There's really no such thing as too much information in this process. We really want to examine the workflows that pertain to addressing road center lines, getting those public safety systems updated. If you're a locality with many municipalities, you'll want to look at that municipality data workflow, especially if they are their own addressing authority. How is that information being communicated to you, and how often? You would not believe the number of clients we speak with who say, look, you know, we haven't heard from our municipality in years. We haven't received updates for years. It's kind of like a black hole. We don't know anything about their addressing. So that might mean bringing in your municipalities and talking to them about their business workflows as well, because it really involves getting everybody on the same page and getting everybody to the table. So after we speak to our different stakeholders and we get all the different information, then we need to look at assessing our GIS data. And we need to look at it from a lot of different standpoints. We need to make sure the data is available, that you can access it, and that it exists. We need to look at the quality. We need to examine the schema and also how it's used throughout your locality. All right. So this graphic is an example of the type of information we would want to gather when assessing an addressing workflow. Knowing simply who the addressing authority is and who the GIS authority is that's going to add it into GIS, that's not enough. It's really not enough. We need to have a thorough understanding of the entire process from the time that the request is initiated. until the time that it moves to the GIS department, to the time it takes them to assign the or to add the address into GIS. Communicate that address out. Who is responsible for each of these things, and how long does it take? So once it's communicated out, how long does it take that data to be entered into public safety systems? And then again, looking at the discrepancy process. What does it look like when a discrepancy is reported by a first responder? How long does it take to get that corrected in the system? So you really need to have as much information as possible. There cannot be too much information here. The more, the better.
Now, Annie, a question came in about next generation 911 and the NG9-1 data requirements related to data management and the 3 business day turnaround. And this is where a workflow is really going to be necessary. So for those that don't know, the National Emergency Number Association has identified that the 911 authority is responsible for data provisioning. Now, whether they do the data provisioning or they have someone else do it in, as their surrogate, they are responsible for that data provisioning and the data quality. So say the emergency call routing function sends down a discrepancy and sends the discrepancy to the 911 authority. There is, per the standard, a 3 business day turnaround requirement for that to be resolved and re-provisioned. Now, what that workflow for you, what it looks like really needs to be vetted out in your community. So in our early adoption, the way we were set up, 911 was regional. There was a regional 911 authority. There was a regional GIS analyst. And so an error received from the 911 system would go to the regional GIS analyst because they were the surrogate of the 911 authority for the data provisioning and discrepancy resolution. That GIS analyst then had to be able to communicate with the local data providers for resolution when they couldn't resolve it on their own. And then that local data provider needed to provide the resolution back, so then the GIS analyst can get it back in the system. And that is supposed to happen within that 3-day business window. And a lot of GIS departments aren't ready to support that because they haven't had to support it before. Now, you can work with your NG core service provider to see if the 3 business day requirements are necessary between the 911 authority and the core service provider. But that's currently what the data management requirements are. And Bill, I hope that was a better explanation than the one I typed out to you. I'm sorry, Annie, go ahead, ma'am.
No, that's okay. So really, identifying the workflow is extremely important because it can also help you identify any potential choke points. We talk to a lot of clients who, throughout their addressing or road centerline process, they do struggle with one department or another being a problem as far as, okay, well, it goes to this place and it kind of dies there until you contact them repeatedly and ask them for a status. So it's very, very important to identify where these different points are where you might be struggling, because that can also help you identify any gaps or needs within your workflow. Sorry, Sandy.
No, don't apologize. We have about 17 minutes left, so Annie and I are going to try to get through the remainder of the presentation within that 17 minutes. We do have some additional questions, and we will follow up with you afterwards for sure. Stephanie will make sure she captures those questions for us. So going back to the purposeful order and how we may tackle our data readiness, one of the things we'd like you to consider is an MSAG to GIS comparison. Now, doing our legacy database comparisons to GIS has a huge amount of value in it. We have to ensure, moving into a next generation 911 environment where GIS is supporting 911, that it's able to do the same or better than what we are doing today. And that's why these legacy to GIS comparisons are valuable. Now, I do want to qualify that if you trust your MSAG data, an MSAG to GIS comparison can be valuable to you. And I say if you trust your MSAG data. Remember, the first 911 call was in 1968. Most MSAGs have been around for decades, changed hands, business needs have changed, and so they may not be the most accurate. But there's still a good resource for information. And if you do not have a road centerline file, it may be a really good resource to get started. Now, what would an MSAG to road centerline comparison look like? You have to remember when we're performing validations for 911, there are always two things we're wanting to know are correct. Is the location valid? And is the call routing to the right 911 setter correct? Is the location valid? And is my call routing valid? If either one of these is wrong, then the call isn't supported completely. The location is valid, but I sent it to the wrong 911 center. Guess what? We get a delay in response. I sent it to the right 911 center, but the address is wrong. Guess what? We get a delay in response. The reality is we have to be able to ensure both of these questions are answered as yes, as being correct when we are validating 911 data. Now, the current standard for synchronization of GIS databases with MSAG and ALI per NENA is NENA 71501, and it's seeking a 98% or better accuracy between your MSAG and your ALI databases and your GIS. Folks, realize that 98% is an attribute-to-attribute comparison, meaning this number and this number are being compared, but it's for the GIS folks, it's not a topological, there's no topological accuracies in these kind of comparisons. It's strictly attribution, and 98% or better is really the goal that we're looking to meet. Now, personally, I don't prefer the term synchronizing because if I synchronize one dirty database with another dirty database and I just get a synchronized dirty database, I would rather just focus on the comparison. And the comparison itself is not saying the MSAG is right and the GIS is wrong, or that the ALI is right and the GIS is wrong, or that the GIS is right and the rest are wrong. It's just comparing these two databases and working with whatever didn't compare. What fell out? What didn't match? Now, when we're performing an MSAG to road centerline comparison, we're doing just that. We're comparing the lows to highs. We're comparing the street names. This is going to be a complete comparison of your MSAG to your road centerlines, as well as where we're routing the calls. That circle should have been on the ESN, and I will fix that before we send it out. But that this ESN and this ESN are actually correct. All right, because again, we need to know that the location that we're supporting and where we're routing the call is consistent.
Okay, so for boundary enhancement, so boundaries play a critical role in NG9-1 because they essentially determine which agency receives the call, right? Therefore, it's important to have all of the required boundaries and also consider additional boundaries that may assist in the call routing process. Many of us now are currently maintaining either response zones or ESZs or ESN boundaries. But NextGen 911 not only requires a PSAP boundary and a provisioning boundary, but also individual service boundaries for fire, law, and EMS. So we as GIS people might be tempted to just do a simple dissolve based on the service type to get those three boundaries. But really, we should not be quick to do that, okay? Because boundaries are not a GIS decision. Boundaries, when they pertain to public safety, are public safety decisions. So we do recommend that you sit with your PSAP and you review these boundaries. It's okay to do a dissolve as a first pass, but we really want to make sure that you're engaging those PSAP staff members in your organization so that you guys can agree on the appropriate boundaries, because really they're the ones who have boots on the ground knowledge, and they're the ones who can tell you where the appropriate boundary is. Okay.
Now, for the public safety folks of the group, remember there are going to be a lot of boundaries that are going to support your NG9-1 call. State, county, your city boundaries, there'll be PSAP boundaries, law, fire, and EMS. Remember, we have all of these boundaries that will now play in our next generation 911 system. And what we have to be mindful of is when we overlay every single one of these boundaries, that we're looking to make sure we don't have gaps or unintentional overlaps within our data set. There are going to be some gaps and overlaps that are going to exist because it's just there's going to be gaps in response or gaps in who's available to support that 911 call. But we don't want that occasion where a 911 call comes in, especially from a PSAP boundary point of view, for there to be a gap there. A gap within a PSAP boundary means that this call has to default route, and that's not what we want. So as part of your data readiness, make sure you don't not only look at every one of your boundaries separately, but when you marry them all together and that 911 call comes in, is it supported by every boundary layer?
Okay, so data normalization is really making sure that our data attributes are standardized across different data sets. We want to make sure that the data is reflecting the same information. So for example, that the naming conventions appear the same in the road center lines as they do in the address points. It's basically a form of QA, okay? So we want to be able, and Sandy, you can go to the next slide so we can show this better. So the data model for Next-Gen 911 really requires us to spell out the directional types and the street suffixes and other things, okay? We can't use abbreviations anymore, although you will need to take into account your legacy data as far as the current systems that your data is already supporting. So if your current systems are accepting data a specific way with abbreviated values, then you might want to move those to the legacy fields within the model to continue supporting your data. But going forward for next gen, it does need to be spelled out. Okay, so data consistency. Really, so address points should be able to geocode along their corresponding road center lines. Okay, and here in this graphic, we have an example of fishbones. And fishbones really show a visual for the geocoding. An ideal fishbone really should be perpendicular or close to it, to the structure, as far as where it geocodes on the street center line. And you can see that on the left there where Sandy is circling. If you look toward the right, you have fishbones that are very steep. And this means that the geocode will occur further down the street and not perpendicular to the structure as it should be. Okay, so it's very important that we have some consistency in our data as far as how we manage our street center lines ranges and the geocoding there, and just be mindful of that because it can have an effect on the call routing.
Especially if this boundary here is going to be your call routing boundary. If your address point is here, but it geocodes here, are we sending it to the wrong place? So that's going to be part of the consistency and quality we're looking for, is not just looking at every data layer, but how well that data layer is coordinated and is consistent with other data layers.
So data quality, it does have several facets. We want to make sure that the data is available, that it exists, and that we can get to it. We want to make sure it's complete. So we want to make sure that all of the attributes are there and that all of the data is there as well. Okay, are you missing address points? This is a really big discussion that we have with a lot of our clients when it comes to data completeness. Accuracy, is it reflecting what's in the real world? How often and how frequently is the data updated? The last thing you want is to provision old, outdated data into public safety systems, because you could find yourselves forcing addresses in Cad. I mean, there's a lot of different things that can go into this when you don't up-to-date data. And then obviously consistency, are we making sure that our data is consistent between systems?
And then the next part of our purposeful order, but again, yours is going to be however you feel is best to implement it, is going to be an ALI to GIS comparison. And much like the MSAG to GIS comparison, what we're doing is comparing those existing ALI records to the GIS. And we're going to want to do this both to site structure address points and to our road centerline files, because we want to see, one, do we have an address point to support it? Yes, we do. But even if my address point can support it, is my road center line going to support it as well? The road center, consider the road center line like your fishnet for getting your call validated and routed properly. So with this, we're going to go ahead and take our ALI records and we're going to geocode it against our road center lines to ensure that the road center line will support it. And then as well, that the ESNs are consistent, that yes, my call is located. Yes, we're routing it to the same place. This can be done within the road center line layer with the ESN left and right field within the legacy fields that are supported by the data schema. Now, what this will also point out to you as part of your geocoding process is where that call is actually going to geocode and where you need to consider changing your road center line on those boundary factors. So in this example, you have a real versus, you have a theoretical versus real addressing. And so these calls, these addresses here actually geocode at the beginning of this theoretical range. If this was a real range, it'd be 123 to 128 and would have geocoded on this end of the range instead. And when we overlay our boundaries, that may have a factor. And then again, for ALI, ALI is going to be the same thing. We're going to take our ALI records and we're going to see whether or not an address point supports it. But then we're also going to look at our ESN, we're going to look at our polygons, and we're going to say, are they saying the same thing? Annie?
Thank you, Sandy. Okay, so data maintenance. I mean, this is very important for GIS folks, and also for public safety folks too, right? As GIS data changes and street ranges change, you want to make sure that your MSAG and ALI are updated. But basically, depending on where you are working, depending on the locality, if you have a lot of development, if you have a lot of data changes, or even political changes like annexations, data can change. Okay, so you might have a lot of additions or deletions, and really, no matter what interval your data is changing, you want to make sure that you set up a scheduled routine process to validate your data. Okay, you want to make sure that you're validating it for the data quality, basically on a schedule, to make sure that if any anomalies are identified, that you can get those corrected. Okay, and that can change. So the more you edit, the more you might want to validate your data, but it's important to have some type of plan in place. So again, we want to make sure with data maintenance that we are engaging our stakeholders, especially if other stakeholders are maintaining the data. We want to make sure that we're understanding who has the authoritative data sets and all of the information pertaining to that as far as the updating frequency, et cetera. We want to make sure that that data is being validated on a regular basis and that any anomalies are being remediated. And that may require you to, again, engage other stakeholders, especially if they're the ones who are responsible for maintaining and editing that data. You also want to take a look at how that data is shared out and any maintenance feedback as far as discrepancies. Again, it's ensuring this process of ensuring that the data is available, complete, accurate, consistent, and all of that. So our next steps that come out of the planning process, really it involves taking a look at your resources and what your needs are. And of course, looking at any gaps either in your workflows or your business processes or in your data quality, and kind of taking a look at that low-hanging fruit, right? So what can you accomplish first with the resources that you have? If you have a staffing need, obviously, you might have to wait until a budget cycle to plan for that. So, that might be more of long-term, but there are things that you can do today, like communication. If you know for a fact that there are stakeholders in your locality who don't have an understanding of what NG9-1-1 is and they need to know. So for example, if you have a planning department who's maintaining your address points, but they don't use any best practices for addressing, this is a good time to start that conversation. Okay, because anybody will tell you that the biggest issue with NG9-1 is not the call handling equipment, the software, or the hardware. It's always going to be in the GIS data, right? That's where the heavy lift is. So having those conversations now and educating people now is very important. Looking at the GIS, what are some things that we can start doing now? Can we go ahead and start creating draft ESBs from the ESZ data that we have? And can we bring in public safety for those other discussions? Let's start looking at our schema. What are we missing compared to the GIS data model? What existing things in our model do we need to have to go forward in maintaining our other systems that our data might support? So like if you have a permitting system or some other type of system, asset management, whatever, make sure that all of those fields are present. Or maybe you want to make sure that you're developing an ETL process. Documentation, succession planning is very important. You want to make sure that if you win the lottery or if something happens, that someone else can take your place when you leave. Okay, and then of course, looking at training needs is very important. You want to plan for that. Again, that might be more long-term depending on your budget cycle, but those are just some things that you might want to start looking at that come out of your planning process.
And folks, we have hit the top of the hour. We do apologize that we weren't able to get the last slide in. Do want to let you know that everything we discussed today actually could probably have its own session on its own, and we do recognize that it's a lot of information to kind of squeeze in an hour. We appreciate all the questions, and we're going to respond back. We do have our second annual virtual public safety conference coming up in April. It is a free conference like it was last year. A lot of these same topics are going to be expanded on, so please consider saving the date for those. You'll see more communication come out about those. And then we are continuing our upcoming monthly webinars. The next one this month will be on NG9-1 data management. Next month will be more information on strategic planning, like Annie just shared. And then in May, after our virtual conference, we're going to be taking up a topic of working with address authorities. Apologize to rush the end of this. The questions that are still out there, we will make sure that we grab them, we respond back to those, and we'll share out a copy of the presentation as well as the video associated to this. Annie, thank you so much for doing this with me today.
Thank you, Sandy.
Everyone have a really great day.